Welcome back, everyone, to West Explains Best. Today we're taking on multiply and divide rational expressions, the basic one on Khan Academy. We're going to do some advanced ones later on, but let's start here. Multiply the following rational expressions and simplify the result. We have 2 over 9y to the 5th times 15y to the 5th over 8 equals something. Now, what most students tend to do, is they tend to just multiply the tops right away. So they're going to take the top times top, bottom times bottom as the rule for multiplying fractions, and they're going to get 30y to the 5th over 72y to the 5th. Although not wrong, this kind of overcomplicates things, and it's much easier if we cancel or reduce before we multiply. So let me go ahead and show how that works. Well, what I notice here is I'm looking for things that have like factors. Well, first off, there we go. So for example, the 2 is in the top, and I need to look for common factors in the bottom in order to cancel or reduce. So I see that the 8 has also a factor of 2, so I'm going to cancel. The 2 gets reduced by 2, leaving you 1, which you don't really need to write, but I'll just show you that it gets reduced to 1. And then we do 8 divided by 2, which is 4. So the top is 1, and now the bottom is 4 for those two respective fractions. Now let's talk about the next numbers that we have. We have 15 and 9. Those both have a factor of 3, so I'm going to divide both of these by 3. I'm going to get 3 in the bottom, and I'm going to get 5 in the top. Lastly, you can also do this with the variables. So if I have y to the 5th over y to the 5th, well, that's just 1. They cancel completely. Now, if I had y to the 5th over y to the 4th, I would cancel all 4 with in the bottom, leaving me 1, 5 minus 4 in the top, or y to the 1st in the top. It all depends. And lastly, if I had y to the 4th in the top and y to the 5th in the bottom, I'd cancel all 4 in the top, leaving me 1 in the top, and then just one y in the bottom. Okay, so that's how that works. Just wanted to show you, but in this case, we're going to cross out all the y's because it's the same. What does that leave us? This is where we got to be careful. We have 5 in the top. Okay, and then in the bottom, we have 3 times 4, which is 12. So 5 over 12 is going to be our final answer. For the result to be equivalent to the original expression, can it be defined as y equals 0? Well, first let me type in my answer. So we have 5 over 12. I think that's what I said. Let me double check that. 5 over 12, okay. For the result to be equivalent to the original expression, can it be defined as y equals 0? Can it be defined as y equals 0? So if we plugged in 0 for y, okay, if we plugged in 0 for y, we'd get 0 over 0. So that would be undefined because we'd have a 0 in the denominator. So we need to say no, it can't be defined as y equals 0, because if we had a 0 in the denominator right here, okay, if we plugged in 0 in for y, we'd have a 0 in the denominator. Okay, that would be 9 times 0, which is 0. Can't divide by 0, so don't want that. Let's check it. All right, next question. Divide the following rational expressions and simplify the result. Same deal, but this time we're dividing. Okay, a lot of students like calling it keep, change, flip. We're going to keep this. We're going to change the division into multiplication, and then we're going to flip this guy. Okay, keep, change, flip. So let's go ahead and show what that looks like over here. 18x to the 5th over 5 times, and then we're flipping this. You always want to do this step before trying to cancel, because otherwise you're going to mess up. Okay, now let's go ahead and cancel. I'm going to start with my numbers. The only ones I think I have is we have this 18 and 8. That can, let's see, 4, nope, 2. 2 is going to be the biggest, so I'm going to divide that by 2. I get 9. I'm going to divide that by 2, and I get negative 4. Keep that negative there. Now I'm going to try to cancel some x's. So here I have x to the 5th, and here I have only 1x. So I'm going to cancel that 1x with one of these, leaving me 4 x's in the top. That's all I can simplify, so now I just need to multiply top times top, bottom times bottom. I get 27 x to the 4th. 9 times 3 is 27, x to the 4th over the 5 times negative 4 gives me negative 20, and then there's no x because that got canceled away. You can tell that these have no common factors. 27 and 20 have no common factors. It's reduced all the way. Okay, so I need to write, I already forgot, 27x to the 4th 7x to the 4th. Oops, I forgot to put this in a fraction. There we go. So 27x to the 4th over negative 20. Double check it. Looks good. For the result, can the equivalent to the original expression be defined as x equals 0? Can it be x equals 0? So here we have to look at, do we have an x in the denominator after we multiply? And we do. Take a look. Before we canceled, we had this x here in the denominator, right here. So we can't put an x in the denominator if it's 0. Can't put 0 in the denominator. Even, and it's always before reducing, before simplifying. So no, we can't put x in there because that'll make it go undefined. Check it. All right, next question. Multiply the following rational expression and simplify the result. This time we have straight multiplication. Take a look here. Even before I cancel, maybe you should do this before you cancel. Notice how we have x's in the bottom. So if we multiply them together, okay, this is not division, so we don't need to change anything. That means we can't have x equals 0. So before I go further, I know it's going to be a no because I have x in the denominator. Can't be 0 because that would make the result undefined. Okay, let's see if we can cancel anything. We have 6 and 9. Those can both reduce by 3. That leaves us 2 and 3. And that's it. Can't reduce the 2 with the 5, and there's no x's in the top. So we have negative 2 times 2 in the top, 3 times 5 in the bottom, and then x to the 3rd times x to the 5th. We get negative 4 in the top. In the bottom, we get 15x, and then we add exponents if we have like bases being multiplied together. So we're going to add these exponents, and we get x to the 8th power. Negative 4 over 15, x to the 8th. Let's type that in. Negative 4. Did I forget something? No. Negative 4 over positive 15. Positive 15, x to the 8th power. Boom. Check it. All right, next question. Last one. Keep, change, flip. So because it's division, we're going to keep this. 12a to the 6 over 5. We're going to flip this into multiplication. That's supposed to be a multiplication symbol. And then we're going to flip this guy to be, oops, forgot to put it over here. 3a over 4. Okay. What do we do from here? Now, let's recognize something. After we rewrote the expression, notice how there's no a's in the denominator. So we can have a be equal to 0 because it will just be like 0 over 20. That's okay. That's equal to 0. It's not undefined. So we can have a equals 0, yes. Okay, so that's something to keep in mind. Now we're going to go ahead and simplify this. Yes, we can. We can cross cancel. We're going to cross cancel here with 12 and 4. 12 divided by 4 is 3. 4 divided by 4 is 1, so it just goes away. So we have 3 times 3 in the top, 9. A6 times a to the 1st, there's an implied 1 there. A to the 7th over 5. So 9a to the 7th over 5. 9a to the 7th over 5. Check it. That is strange. Can the result equivalent to the original expression be defined as a equals 0? Suppose no, huh? Well, that one fooled me. I guess you can't even have it because you can't have this a at all in the denominator where that's equal to 0. I thought for sure it was going to be the other way. Well, what do you know? We all make mistakes. If you want me to do more problems just in case, leave a comment. Otherwise, thanks for watching. Have a great day. Hope you come back for more.